In this tutorial, we will learn how to write template functions in C++. Template functions are powerful C++ constructs that allow us to write generic functions or algorithms without worrying about a specific data type. This is sometimes referred to as generic programming. So let's take a simple example and say I want to create a function that returns the sum of two values. And let's say for this purpose, I want to return the addition of two double precision variables. If I wanted to do that, I first create the interface like this. Double add them, and then I want to take in two parameters, double first and double second. Now that I've created the interface, let's come down here and write the implementation. Double add them, and again I want to return the sum of two variables, first and second. So that would be the method for which I would write a generic or a specific function. Now if I want to write a function that does this operation for any data type, which can be double uint64, int64, any of these types. It can be our own user-defined types. It could also be a class or structure if we define the plus operator for it. If I wanted to do that, I'd be creating a template function. So in order to create a template function, I first need to write the keyword template in front of the function I'm going to write. Now, in an angle bracket, I'll write type name T, where T will represent whatever type we want to put in there. Now, I've declared this as a template function, and instead of operating on doubles, let's operate on this type name T. That's how you would declare the interface to a template function. Now coming down here to our implementation, we're going to do the same thing. Template, type name, T. And then for every variable that we want to be generic, in our case we want both first and second to be generic and the return value to be generic, we'll replace that with T. And there we have it. So that's how you create and implement a template function. Let's look at how you would use it. So to call this function, let's create a couple of variables. To call this, I would do add them. I would then add an angle bracket, and specify the data type. In this case, double. And then, like a regular function, I would just input the parameters, D1, D2. And that's it. So let's check our work and see if we can implement this. If I want to add them, I'll just do a simple cout. There we go. And to verify that the results we get are going to be a double, let's go ahead and just print out the size that we expect. Next, let's say we want to do this same function for an integer. And let's do the case of an int32. let's also print out the size of the result for this function. Now that we've done that, let's go ahead and compile our program, and we'll jump on the command line and give it a test. So what we have here is, in our code, we add 3 plus 1.5, which we get our expected value of 4.5. Now, comparing the size of the result to what we have up here, a double, we can say that, yeah, we're returning a double data size. And then for our int32, we add 5 and negative 2 with an expected result of 3. And so we get our result of 3, and then when we take the size of it, we get our expected result of 4 bytes.